IB Year 11 exam, June exam, section B. Question 7. Draw Lewis electron dot structures for C2H4 and N2H4 showing all valence electrons. Well, C2H4 has got 2 carbons joined by a double bond, and each carbon is connected to 2 hydrogens. So I've actually picked one of these up earlier on. I'm just going to copy this. I'm going to paste it in here. There we go. So this is the ethene Lewis structure. You'll see there's 2 shared pairs of electrons between the 2 carbons, and each carbon is connected to 2 hydrogens. We also have to do a hydrazine. Nitrogen joined to another nitrogen, and each nitrogen holding 2 hydrogens. So I'm just going to insert this here as well, so we can look at the difference. Let's put this one in here. We can see that hydrazine, each nitrogen has got a lone pair of electrons. The nitrogen is joined to the nitrogen by a single bond, and there are 2 lone pairs, one on each nitrogen. This will be for the 2 marks, the Lewis structures. State and explain the HCH bond angle in ethene. Well, ethene, we've got 3 regions of electron density. So the 3 regions of electron density arrange themselves into a trigonal planar structure. Trigonal plane. This has got a bond angle of 120 degrees. And that's why the CC bond is going to be HCH bond angle is going to be 120 degrees. In the HNH bond angle, however, there are 4 regions of electron density. Perhaps I should have said here ethene. Ethene, 3 regions of electron density. What's happened here? Compared to some here. In hydrazine, there are 4 regions of electron density. So these arrange into a tetrahedral density. Arranged tetrahedrally. Now a tetrahedral bond angle is 109.5 degrees. So we'd expect this to be the bond angle between the hydrogens, nitrogen, hydrogen, to be 109.5 degrees for our 2 marks. Part B. The polarity of a molecule can be explained in terms of electronegativity. Define the term electronegativity. Well, electronegativity is the attraction of an atom for electrons in a bond. This is the key. It is attraction for electrons. For an atom, an electron, but it attracts them only along a bond. So the power of attraction, if you like, the power of attraction of an atom for electrons in a bond. Compare the relative polarities of the CH bond in ethene and the NH bond in hydrazine. Well, the relative polarities are given by the difference in electronegativity. So the difference in electronegativity between C and H is much less than that of N and H. And we've got electronegativities in the data booklet if we want to look at them. C and H. So in other words, therefore, the NH bond is much more polar. We put figures on it. Carbon's electronegativity is given in the data booklet as 2.5. Allah, what's happened here? I know what's happened here. I'm just got the wrong language. is 2.5. Hydrogens is 2.1. 2.1. Nitrogen is 3.0. Put that in brackets. And hydrogen, as we say, is 2.1. So you can see there's a bigger difference between nitrogen and hydrogen than there is between carbon and hydrogen. Well, this is only for 1 mark, so you don't need to go into that full explanation. Hydrazine is a polar molecule and ethene is non-polar. Explain why ethene is non-polar. Ethene is non-polar not just because the bonds have little polarity, but any polarity is cancelled out by the symmetry of the molecule. The overall polarity is the vector sum of the individual dipoles. And these cancel out in the case of ethene. In the case of ethene, due to the symmetry of the molecule. These cancel out. Symmetry of the molecule. The boiling point of hydrazine is much higher than that of ethene. Well, let's go back and have a look at them and see if we can see why. So this has got a much higher boiling point. We can see that nitrogen, which is electronegative, is attached to hydrogen. This allows the hydrogen to bond to other hydrazine molecules using hydrogen bonding. This can't happen with ethene. So there is extensive intermolecular hydrogen bonding in a sample of hydrazine. This cannot occur with ethene. Perhaps we should say there's extensive intermolecular hydrogen bonding in some hydrogen due to the hydrogen atoms being attached to electronegative nitrogen atoms. And that gives a reason as well. And we said can't happen with ethene. And there's your 2 marks. That, I believe, is the end of the paper. Okay, the last question depends on us working out the equation of the reaction between hydrogen and oxygen using bond enthalpy data. Exactly the same as before. This time we just have to decide, find what the actual atoms are. In hydrazine, N2H4. Go back to the picture of hydrazine. You see there's 1 NN single bond, 4 NH single bonds, and that's it. So we run it back forward again. So we add up an NN single to 4 NH bonds, and don't forget there's 1 OO double bond. Add those up and that becomes 2220 kilojoules. And then we look at the products. 1 N triple bond N for the nitrogen, 4 OHs, that gives minus 2801. And so the overall enthalpy change is 2220 minus 2801, which is minus 581 kilojoules.